Now that we've learned all the different exponent rules from this section, we need to be able to apply them as needed. So we're going to just simplify each of these expressions using any exponent rules needed. In our first example, we have 4 to the 4th minus 4 to the 0. Now, this subtraction means that these are completely separate terms. There's no multiplication, there's no division, there's no power rule. These are separate terms. So let's look at the first term, 4 to the 4th. That's 4 times 4 times 4 times 4, which is 256. And now a subtraction, and the second term, 4 to the 0. Now this is the 0 exponent rule. Any base to the 0th power is 1. So this just becomes 256 minus 1, which is 255. In our second example, x to the 0 to the 5th. Okay, so for this term, we've got to apply the power rule. We'll multiply power. 0 times 5 is 0. And then our next term, we have another power rule. So we're going to multiply 0 times 6, which is 0. And now the first term, x to the 0, that's the 0 exponent rule. And 3 to the 0 is another 1. So 1 plus 1 is 2. In our third example, we've got a numerator and a denominator. But our numerator is stuck inside of this product to a power. So we do have to multiply, or we have to give that power to all of the factors in the numerator. So the first factor of 2 gets that power of 3. The second factor, a to the 3rd, gets that power of 3. And the third factor, b to the 4th, gets that power of 3. So, 2 to the 3rd is 8. A to the 3rd, that's a power rule. So we're going to multiply those together. And that gets us a to the 9. And there's another power rule. B to the 4 times 3 is 12. Okay. So now I can look at the quotient for the numerical factors. If you do 8 divided by negative 8, that's negative 1, times the base a factor. A to the 9 divided by a to the 9. So that's a quotient rule. I'll subtract the exponents. And base b is another quotient, so I'll subtract the exponents. All right, so we have negative 1. And if we subtract 9 minus 9, we get a to the 0. And if we subtract 12 minus 2, we get b to the 10. So a to the 0 is just 1, right? So that's going to be negative 1 times b to the 10, which is just negative b to the 10th. For our third example, we have a quotient to a power. So we can give that power of 0 to each part of this quotient, right? But you know what's easier? Why don't we just say any base raised to the 0th power is 1. You'll find that that's true even if you give that 0 power to all of those factors. You'll find that they're all going to be multiplied by 1, divided by 1. So really, this is 1 divided by 1, which is 1, right? You'll find that that's true no matter what. Any base raised to the 0th power is 1.